What's up, math fans? Today we're talking about systems of equations using elimination, and then I put difficult. I don't want to say it's difficult, I don't want you to get scared. It's just more difficult than the last video I did. So you have to know what I did last time first. So if you didn't see it yet, go back and check it out. It's the same thing, systems of equations using elimination. It just doesn't say difficult. All right, so it's just the regular introduction. What happens is you have two equations, that's a system, and you want to solve. And I did some easy ones where I looked at my variables. I got A and B, B and A and B, and they lined up so perfectly that I called it elimination because I just eliminated. So I looked at it and I put a giant plus sign and I automatically crossed out. So let me just cross these out. Oh, wait a minute. 5 bananas and 2 apples don't cancel out. How about 8 apples and negative 5 bananas? That doesn't cancel out either. So it was so beautiful in my last video that I was doing, all of a sudden it's not that beautiful, so you actually have to think. So let me think. Could I cross out anything? First of all, something I didn't really make clear, the variables got to be lined up. A should be over A, B should be over B. So I'm going to use the switch it property, switch it, commutative property that says 5B plus 8A is the same as 8A plus 5B equals 9. So this is the same as line 1. I just rewrote it. And line 2, I'm going to just rewrite without switching anything. Here, I use the commutative property to rewrite it. And here, so this, commutative, and then this, I did nothing. Now, I can remind you of how I solve systems of equations using elimination. Giant plus sign, 5 bananas, negative 5 bananas, goodbye, no bananas. 8 apples plus 2 apples is 10A equals 9 plus negative 4 is 5. And then I'm going to divide by my coefficient, and A equals 5 over 10 or 1/2 or 0.5, whatever makes you happy. I'm going to go with 1/2 for now. And I'm not done yet. I got to go back to the beginning, choose my favorite equation. I like the first one, 5B plus 8A equals 9, but I know that A is half. So 5B plus 8 times a half equals 9. 5B plus half of 8 is 4 equals 9. Subtract 4 on both sides. 5B equals 9 minus 4, again is 5. That's convenient. Divide by 5, and B equals 1. If you remember, when I want my solution, I write it as half, comma, 1 in alphabetical order, A, comma, B. Okay, that I would consider easy because I line up the letters and it cancels out right away. Take a look here. The variables are lined up, but there's nothing that can cancel. That's when it gets tricky. That's when I want to take your attention to this. If you have a calculator, you'll know what I'm talking about. You want to press math, slide over to the number column, and go down until you see L.C.M. And we're going to talk about what this means. Let me just clear some space. Okay. Please get comfortable with pausing and rewinding the video, so in case you miss anything, you can go back. I repeat myself. If you rewind it, I repeat myself. If you rewind it, I repeat myself. All right, so I want some of these variables to disappear. I don't know what to do. So let me think ahead of what I want. I wish that the same number was here and here. Or I wish that the same number was here and here. I would like to either cancel out the x's or the y's. You can choose. I'm going to go for trying to cancel out the x's, but they're not the same number. So you have to be able to make them the same number. And you are allowed to do that. If you're not sure about rules in math, you can always say, well, let me see if it makes sense. Let's say x is 5. This is random. This is not an example yet. If x is 5, is it true that 2 times x, double x, is equal to 10? Yes, it is. Why? Because you are allowed to do whatever you want as long as you do it to both sides of the equation. So basically what I did was I doubled the x and I doubled the 5. You can do that. Let's say x plus y equals 9. You can double both sides here and tell me that 2x plus 2y equals 18. That is absolutely true because basically you are doubling both sides like that, all right? So the point of the story is you can do whatever you want as long as you do it to all members or all terms of both sides of the equation, okay? So I want to somehow magically get these two to be turn into the same number, and that is considered the LCM. So if you're not sure what the LCM is, I want the LCM of 5 and, if you put the comma on the calculator, it means and, 5 and 2. What is the least common multiple of 5 and 2? What is the smallest number that 5 and 2 both go into? Count by 5s, count by 2s. When do they meet? 10. So you want a 10 here, you want a 10 here. I want a 10 as the x coefficient. So then you again, because a lot of people say, oh, where did the 10 come from? It came from knowing what my LCM of 5 and 2 is. Now you just got to think, well, how do I turn a 5 into a 10? Multiply by 2. How do I turn a 2 into a 10? Because I want a 10. Oh, here I multiply by 5. Is it a coincidence that this 5 goes here and this 2 goes there? Yes and no. Usually the LCM comes from just multiplying the other number. Sometimes it doesn't. For example, let's say you wanted the LCM. Go back to 3rd grade for a second. You wanted the LCM of 6 and 9. I don't necessarily have to multiply them together. See here, LCM of 5 and 2 is 10. You multiply them together. Here, LCM of 6 and 9 is 18. So you don't always multiply them together. Sometimes it's less. Count by 6s, count by 9s, you'll figure it out. All right? This is just an example. All right, okay, in case you forgot, call your 3rd grade teacher. They'll remind you. We're going back to the real math. So, you are allowed to do this, and you are allowed to do this. This is my old line 1. What's my new line 1? 10x minus 2y. Nope, forgot to multiply already. 10x minus 4y equals 40. Okay, multiply here, here, and here. All terms. Now here's going to give me 10x, does this look like a 4 to you? 10x plus 15y equals 5 times 27. I wish I had a calculator and then I would know it's 135. Now I can cross them out because they're the same. But they're not only supposed to be the same, but they're supposed to be inverses. One should be positive and one should be negative. So I still didn't get it right. Should have multiplied by -5. This would have given me a negative 10x and a negative 15y and a negative 135. Now you can put your giant plus sign and finally get to work. So what makes this difficult is you got to do a whole entire step before you can even start. And that whole entire step is figuring out what the LCM is, creating it, and distributing to all terms. Now, goodbye, that was easy finally. -4 plus -15 is -19y equals -95. Check my work. Divide by -19, divide by -19, negative divided by negative is positive, and 95 divided by 19 is 5. Check my work. So I'm done, and I'm happy, but I'm not done. Go back. I'm gonna go with the second one, because I like plus signs. So 2x plus 3y equals 27. Remember what to do? Take out the y and replace it with a 5. Substitute the 5 equals 27. That's a 2. 2x plus 15 equals 27. And finally, we're down to a basic two-step equation, and you're probably smooth sailing from here. Subtract 15 on both sides. 2x equals 12. And x, if I divide by 2, x equals 6. You probably cannot see that, but if x is 6, and again my answer should be x comma y, so that's 6 comma 5 is your solution. Okay, any questions on that? None? Great. Oh, the tie. Yeah, I was thinking about this tie and I wanted to spend some money, so I went on Toys R Us or BabiesRUs.com to order some diapers. Did you know that you can't say the word poop on Babies R Us because my card was going to say, hey, hope this helps with the poop. And they said, no, your message can't be sent. Please rephrase the vocabulary. Can't say poop. All right, thanks for watching. See ya.